So hopefully you've practiced the square root of x graphs and you're feeling kind of confident in that. What we're going to do now is cubed root of x. So I really want to show you the difference between an even root and an odd root. So if we're going to take the cubed root of x, are there any restrictions in the domain? Is there anything that you can't take the cubed root of? Well, the answer is no. There are no restrictions in your domain. You can choose anything from negative infinity to infinity, right? X is an element of the real number system. This is going to be the domain of my graph. What we want to look at is what's the range and how would we graph this? Well, if I was going to graph a cubed root of x graph, I want to grab things that are perfect cubes. So for example, 0 cubed is 0, right? 1 cubed is 1, 2 cubed is 8, and then we'll choose -1 and -8. So just like with your square root of x function, there's like specific x values that you're going to choose. And for a cubed root of x, I choose -8, -1, 0, 1, and 8 because they're perfect cubes. If I take the cubed root of -8, I get -2. If I take the cubed root of -1, I get -1. If I take the cubed root of 0, I get 0. The cubed root of 1 is 1. And lastly, the cubed root of 8 is 2. And this is going to give me the points that I'm going to sketch. So we're looking at what does a base cubed root function look like? Well, I'm going to start at that 0, 0 mark, and then it goes a 0.11, and then a 0.82. And that's as much as we have to do because then it goes off the grid. And so then we're going to go -1, -1, and -8, -2. So these are my points that I'm going to sketch. So this is going to be my base shape of a cubed root x function. The domain is negative infinity and infinity, and then what's the range? Well, I've got these arrows, right? So it's going down to the left, it's going up to the right. The range is actually negative infinity to infinity. So even root graphs get lots of restrictions. Odd root graphs have no restrictions. The domain is XER, the range is YER. Okay, but now let's do the things to it. So the first thing we're going to do is graph y equals the cubed root of x plus 2. The first thing is this question becomes a little bit redundant. Are there any restrictions in the domain? No, right? The domain is going to be negative infinity to infinity. So what should I choose for x? Think about your square root of x graph. Is there a number underneath the radical sign? No, it's outside. So this is not going to affect my x values. This is going to affect my y values. If you're thinking ahead, think about the Desmos that we just did. Here, I'll pause this and erase the. Okay, there you go. I don't have to wait through the erasing. This is y equals the cubed root of x. Okay, this is my base shape. What we're talking about is what if I put a number on the end, like a +5? What do you think is going to happen? Is it a transformation on x? Is it a transformation on y? Where do you think it's going to go? Well, let's see. It went up. I took the cubed root and then I added 5, so it made my graph go up 5. Whereas if I did the same thing again and I went -5, it's going to go down 5. What if I put it underneath the cubed root sign? What if I go +5 in here? Oh, it's the same as my square root graph. Now instead of starting at 0, 0, I'm starting at -5, 0, but I've got that same shape. And then lastly, if I was to put in -5, it's going to go to the right 5. Okay. So let's go back to the note. How are we going to graph this? Well, the transformation is not on x, so we're going to choose -8, -1, 0, 1, 8. So let's go -8, -1, 0, 1, 8. And that's the biggest thing. Like if anybody's being confused about what I'm talking about, it's choosing your values of x. If there's no number under the radical sign, choose the normal numbers we use. For a square root graph, it's 0, 1, 4, 9. For a cubed root graph, it's -8, -1, 0, 1, 8. That is all you need to know. Then you plug them into your table of values. So I end up with the cubed root of 8, -8, plus 2. Well, the cubed root of -8 is -2, plus 2 is 0. Then we plug in -1. We've got the cubed root of -1, then we're adding 2. So that's going to be -1 plus 2, which is 1. Then we're going to plug in 0. The cubed root of 0 is 0, plus 2 is 2. Then we're going to plug in 1. Y equals the cubed root of 1 plus 2. That's going to give me 1 plus 2, which is 3. And then lastly, when I plug in 8, I've got the cubed root of 8 plus 2, which is going to be 2 plus 2, which is 4. And again, there's this pattern in the y values. So math is like this. People are like, well, why do you have to keep plugging the numbers in? Don't. If you see the pattern and you know you're picking the right x values, that pattern will happen. Don't plug them in. Don't do this work over here. That's totally fine with me, right? In fact, if I was going to graph this, I don't even do the table of values. I'm like, okay, so instead of starting at 0, 0, this graph's going to start at 0, 2. Then I'm going to go over 1, up 1, over 8, up 2, right? Does that match my points? Well, I've got a point at 8, 4, I've got a point at 1, 3, and I've got a point at 0, 2. Sweet. Then I'm going to go the other way. I've got a point at negative 1, 1. I've got a point at negative 8, 0, right? Over 1, down 1, over 8, down 2. Totally up to you. If the whole over and down thing makes no sense to you, ignore it. If the table of values thing makes no sense to you, ignore it. You've got to decide what makes sense to you. And then for this graph again, the domain is negative infinity to infinity, and the range is negative infinity to infinity. Awesome. So then I've just thrown in one more. What if the number was underneath the radical sign? Are there any restrictions in the domain? No. It's still negative infinity to infinity, but this is going to affect the x values I choose. Normally I pick negative 8, negative 1, 0, 1, 8, but this is going to make me add 3 to all of those x values. It's going to make the graph go right 3, and that is the hardest thing to explain. Now, I'm doing this assuming that you can all follow it. If you're lost at all, I mean, you can really just pick any x values you want, right? I mean, there's nothing wrong with picking negative 8 and plugging that in as it is, but then you're going to be taking this cubed root of negative 11, and you're not going to want to graph it. So if you want to do this right, or not right, sorry, if you want to do this the easiest way possible, you got to look at this and be like, okay, if this was a square root of x graph, I'd be saying x minus 3 has to be greater than or equal to 0, which means my graph would be starting at x equals 3. Okay, what happened? That made my x value go up 3. So we're going to make all of the x values go up 3. So then plug them in, whether you know what's going to happen or not, right? It's easier just to plug them in. So we've got the cubed root of negative 5 minus 3. Oh, I'm getting the cubed root of negative 8, which is negative 2. Can you guess the pattern, or can you remember the pattern? Is it going to go negative 1, negative, or negative 2, negative 1, 0, 1, 2? Let's check. Let's plug in 2. I've got the cubed root of 2 minus 3, which is the cubed root of negative 1. Oh, that's negative 1. Then if I plug in 3, I've got the cubed root of 3 minus 3, which is the cubed root of 0, which is 0. When I plug in 4, I've got the cubed root of 4. Oh, right, it's minusing 3, so it's going to be the cubed root of 1, which is 1. And then lastly, 11. The cubed root of 11 minus 3 is the same as the cubed root of 8, which is 2. And then graph these points, or use the idea of transformations, right? Normally this graph starts at 0, 0. This one's going to start at 3, 0. I'm going to go over 1, up 1, over 8, up 2. Doesn't quite fit. Over 1, down 1, over 8, down 2. Or just plot your points, right? Negative 5, negative 2. 2, negative 1, 3, 0, 4, 1, 11, 2, and then just connect the dots. It's kind of a choose your own adventure. What do you understand? If you're going on to Math 60, start thinking of it as transformations. This is a normal graph, move to the right 3. If you're like, oh, I don't know, this graphing thing is hard enough on its own, just think about the values of x that you choose. If there's a number under the radical sign, that affects the x's you choose. If the number is outside of the radical sign, it does not affect the values of x that you choose. Just finishing this guy off, the domain is negative infinity to infinity. The range is negative infinity to infinity. If anybody's still struggling, let's just, like, I'm not going to actually do it, but let's just look at what if it was y equals the cubed root of x plus 5. Let's just think about the table of values that I would choose. Okay, so we're not going to actually graph it, but let's just think about my table of values. I feel like this is the hardest part. Where would it start? So we're thinking about where that middle would be. Okay, normally it's -8, -1, 0, 1, 8. Because it's x plus 5, the graph middle is going to be at -5, right? That 0 point is going to be at -5. So what am I doing to all the x values? Well, I'm going to minus 5 from all the x values. Okay, it's going to go left 5. So all of these points we're going to minus 5 from. So you'd end up with a point at -13, -6, -5, -4, and 3. Right? And then if you plug it in, you'll get y is -2, -1, 0, 1, 2. Hopefully this makes sense. If it doesn't, please reach out and ask. It is something that we'll be doing again in Chapter 8 when we're graphing quadratics.